Welcome back. In the past couple of days, we've been looking at graphing inequalities, but out of context. Today, we're going to look at graphing an inequality, but in application, so that we can actually see how they are used and how they can benefit us. So let's look at our first scenario. It says, suppose your budget allows you to spend no more than $24 for decorations for a party. Streamers cost $2 a roll, and tablecloths $6 each. Use intercepts to graph the inequality that represents the situation. Find three possible combinations of streamers and tablecloths you can buy. Now there's a lot that's going on in this word problem, so let's break it apart and take it piece by piece so that we understand the problem fully. It says, suppose your budget allows you to spend no more than $24 for decorations for a party. Now, when a word problem tells you no more than, at least, fewer than, greater than, more than, those are all phrases that we use to represent inequalities. Now, when it says no more than $24, that means that you can spend up to $24, including $24, because no more than means up to and including that value. But you can't spend anything more. You can't spend $24.25. You can't spend $25. Anything over $24, you don't have enough money for. So you can spend anything up to. Now, when it says no more than 24, that doesn't mean you have to spend all $24. You could spend $20, you could spend 22, you could spend 21.50. So that means any value up to and including 24. So we know that our inequality is going to be less than or equal to 24 when we write it. Now let's keep reading. It says streamers cost $2 a roll and tablecloths cost $6 each. Now they're not telling you how many of each you're going to buy, but they're telling you their cost so that you would be able to calculate that so that you don't spend any more than $24. It says use intercepts to graph. Now, in the past couple of exercises that we have been working when we have been graphing these inequalities out of context, we have been rewriting the equations that they give us in slope-intercept form. So here's an example to where they're going to show you how to graph the line in the inequality, the boundary line, using intercepts. Now the reason they're going to use intercepts here is because this is a real life situation. So our graph will only be in quadrant 1. So it's going to be really important for us to know what our intercepts are so that we know where our line begins and ends in our graph. So we're going to be using intercepts to graph this boundary line that represents our inequality when we write it. Then the last statement says, find three possible combinations of streamers and tablecloths you can buy. Now what they're saying here is how many different rolls of streamers and how many tablecloths can you buy for your $24? And those solutions, which there will be many solutions, because remember when we graph inequalities, all of our solutions are in the shaded regions. Now, for a problem like this, you can't buy half of a tablecloth, you can't buy half of a roll of streamer, so our answers here will only be the integers in the shaded region. But we'll talk more about that in a moment. Okay, so again, this is a word problem, so we have to start off by defining variables if they don't define them for you. So let's define variables. We are looking for the number of rolls of streamers and the number of tablecloths. So let's define those first. All right, so let S equal the number of rolls of streamers, and let T equal the number of tablecloths that we will be purchasing. So we defined our variables right here. Now, from the word problem, what do they say about the number of the rolls of streamers? They tell us right here that streamers cost $2 a roll. So that means 2 times S will help us determine how many rolls of streamers we can buy. They tell us that the number of tablecloths costs $6 each. So every time we buy a tablecloth, our cost increases $6. But remember, we can only spend up to and including, meaning no more than, as it says in the problem, no more than $24. So that means less than or equal to 24. So we have just written our inequality. 2s plus 6t is less than or equal to 24. Again, this must be less than because it says right here that you can spend no more than $24. All right, now that we have our inequality, they tell us in the directions that we have to graph using intercepts. So let's do that. All right, so we have our inequality. 2s plus 6t is less than or equal to 24. Now don't forget how to find intercepts. Intercepts are when you substitute a 0 in for one of your variables and then simplify. So if we find the x-intercept, and in this case x represents our s because that's the first one that we defined, and then also here in our graph we put rows of streamers on the horizontal axis. So our streamers are representing our x coordinate, or our x value in our graph. So let's put a 0 in for t, because remember, if we're solving for the s or x-intercept, you have to put a 0 in for the other variable. So 6 times 0 gives us 0. So that would leave 2s is less than or equal to 24. And to get s by itself, we would have to divide both sides by 2. And 24 divided by 2 is 12. So we know that our x-intercept, or in this case our s-intercept, is 12. Now let's find our t-intercept, or when we graph out of context, we call this the y-coordinate. Remember, when you find the y-coordinate, you substitute a 0 in for your x-coordinate, and in this case the s. So this time we're going to put a 0 in for the s. 2 times 0 is 0, so this is gone. And that leaves us with 6t is less than or equal to 24. Well, we have to get to t by itself by dividing both sides by 6. 24 divided by 6 is 4. So we have found our two intercepts. Remember, your intercepts are points. I told you guys that when you write an intercept, you have to write it as an ordered pair, and one of your coordinates has to be 0 depending on which intercept you just found. Now, we stated a moment ago that we will only be graphing in quadrant 1. Well, why is that? Well, think about it. We know that quadrant 1 is where both of our variables, x and y, or in this case s and t, have to be positive. Ask yourself this question: does it make sense to buy a negative number of tablecloths or a negative number rolls of streamers? Since it doesn't make sense, we can't use quadrants 2, 3, or 4 to graph our inequality. Now, be careful, because there may exist some situation to where a negative number could make sense, possibly dealing with temperature or money in a bank account if you overdraw. So don't always assume that when working a word problem, that it'll only be in quadrant 1. You have to read the problem and see if it makes sense for those to be negative numbers. All right, so we said we are letting s equal the rows of streamers. So remember, in application problems, you have to label your graph. So we put rows of streamers here and tablecloths up here on the side. Let's go ahead and graph those intercepts. 12, 0. From here, they're counting by ones, so we plot 12, 0 and put a dot. Then we're going to graph the other intercept, 0, 4. We put 0, 4 and put a dot, and we draw our line. Now, we have to ask ourselves before we draw our line, just like before, is this going to be a solid line or is it going to be a dashed line? Well, again, we determine that by looking at the inequality symbol. Since this inequality symbol also contains the equal to, this is a solid line. This only would have been less than or greater than, this would have been a dashed line. So the rules don't change. All right, we now have our line. Now, unfortunately, when we graph using intercepts, instead of rewriting our inequality into slope-intercept form, we can't easily see whether we're going to shade above or if we're going to shade below. So we have to pick a test point. Okay, so the easiest test point here is to put 0, 0 in. That'll help us determine if we're going to shade above this line or below. So let's put a 0 in here. 2 times 0 is 0. Put a 0 in here. 6 times 0 is 0. 0 plus 0 is 0. So is 0 less than or equal to 24? Is that a true or false statement? Is 0 less than or equal to 24? Well, that's a true statement. 0 is less than 24. So since that's a true statement, we're going to shade the side that represented our test point. Since the test point we substituted in was here, and it was true, that means we have to shade below the line. Okay? So by using that test point, we know that 0 is less than or equal to 24. So we will shade below the line. So here's our graph now with the shaded region. But we're not finished. Now, and when we were working these problems before, after we shaded, we were done. But this question had one more statement to it. It said, list 3 possible combinations for the number of streamers and tablecloths you can purchase. Well, as we said below, that the solutions lie in the shaded region. So since we shaded below the line, all of our solutions are down here. Now, we also stated a moment ago, too, that it doesn't make sense to buy half of a tablecloth or a third of a roll of streamers. So that means that our solutions have to be integers. So you don't want to give any parts of numbers here as one of your 3 possible combinations. So any integer, ordered pair, point, however you want to say it, in the shaded region can be a solution, but make sure it's in the shaded region. If you get too close to that line and then you give me an ordered pair that's above the line, it's not going to be a solution. So let's look at some possibilities here. We could say that, remember this represents the rolls of streamers, we could buy 1 roll of streamers and we can buy 1 tablecloth. That's in the shaded region. That would be that point right there. That would be 1, 1. That's a combination. Or we could say buy 1 roll of streamers and 2 tablecloths. We could say 1 roll of streamers and 3 tablecloths. Now we couldn't say 1 roll of streamers and 4 tablecloths because that point would be right there, and that is no longer below the line, it is above the line. So 1 roll of streamers and 4 tablecloths would not work. And you would be able to check that by substituting that ordered pair back into the original inequality, and you would see that it wouldn't be true. Let's look at some other combinations. We could say that we wanted 2 rolls of streamers and 1 tablecloth, or 2 rolls of streamers and 2 tablecloths, or 2 rolls of streamers and 3 tablecloths. But we would not be able to say 2 rolls of streamers and 4 tablecloths because, again, it would not be in the shaded region. We could come over here and say 3 rolls of streamers and 1 tablecloth, 3 rolls of streamers or 2 tablecloths. Now be very careful right here. This appears that 3 rolls of streamers and 3 tablecloths are on the line. But what if you have a little bit of human error and that 0.33 actually was slightly above the line? It's easy to get a little bit messed up when you have to draw the line. So my suggestion would be stay away from that line in case you didn't draw it quite correctly. And we could continue this. We could say that we could buy 5 rolls of streamers and 1 tablecloth, 5 rolls of streamers and 2 tablecloths, 6 rolls of streamers and 1 tablecloth, or maybe we want to buy only 7 rolls of streamers and no tablecloths. That point right there. Okay, there are so many different possibilities. Another possibility would be no rolls of streamers and 4 tablecloths. Now we're sure at this point because it was an intercept. We could also come down here and say 7 rolls of streamers and no tablecloths. As long as it is in that shaded region and you are absolutely sure it's on the line, then that would be a possible combination. So we could pick any 3 combinations that we want here. So for this demonstration here, I said 9 rolls of streamers and 1 tablecloth, 6 rolls of streamers and 2 tablecloths, or 3 rolls of streamers and 3 tablecloths. But again, my advice to you, because you're going to be drawing by hand, when you go to pick your solutions, try to stay away from the line if you can, unless you are absolutely sure that point is on that line. All right, you can watch this video as many times as you need to see how to solve these simple problems. And once you feel comfortable, you can start your exercises. Good luck.